Ms. Lee's Chemistry Academy, Lab 5, a kinetic study reaction of calcium carbonate with hydrochloric acid. Investigation. In this investigation, you will need to design an experimental procedure to determine the rate order of a reaction between calcium carbonate chips and dilute hydrochloric acid. In this experiment, you'll perform graphical analysis to determine the rate order for the reaction. Chemistry principles. Before beginning this lab, you must understand some of the chemistry principles involved. Calcium carbonate solid reacts with hydrochloric acid according to the following equation below. By connecting the sealed reaction vessels to a gas syringe, the carbon dioxide gas evolved will push the plunger of the syringe to fill a volume, and the time of the reaction can be measured from start till the plunger stops movement, signaling completion of the reaction. In this lab, 3 grams of calcium carbonate is reacted with 50 milliliters of various concentrations of hydrochloric acid ranging from 5 molar to 0.5 molar to collect reaction time data. The linear relationship from the plots of concentrations of hydrochloric acid versus time can be used to derive the rate of the reaction with respect to the concentration of hydrochloric acid. Pre-lab calculations. For the pre-lab, you will need to determine which is the limiting reactant when the 2 extremes of hydrochloric acid concentrations are used. The calculations are shown below. These calculations show that hydrochloric acid is the limiting reactant. Pre-lab calculations. In these calculations, 2 extremes of hydrochloric acid are used, but the calcium carbonate is the limiting reactant as shown below. Procedure. To begin this lab, you must use a stock solution of 5 molar hydrochloric acid and prepare 50 milliliters of a 0.5, 1, 1.5, 2, 2.5, 3, 3.5, and 4.5 molar hydrochloric acid using the equation shown below. Procedure continued. Then react 50 milliliters of the hydrochloric acid ranging from 5 molar to 0.5 molar with 3 grams of calcium carbonate in an Erlenmeyer flask fitted with a rubber stopper connected to the gas syringe by glass and rubber tubing. Then record the time with a stopwatch from start till the plunger of gas syringe stops movement. Once finished, plot 3 graphs of concentration of HCl versus time, natural log of the concentration of HCl versus time, and 1 over the concentration of HCl versus time. Use the resulting linear graph to determine the reaction rate order with respect to HCl. Data table molarity of hydrochloric acid versus time in seconds. The data table below shows the molarity of hydrochloric acid and the time it took to fill the syringe. As you can see, the time is decreasing as the molarity increases. Concentration of HCl versus time plot is not linear. Reaction is not zero order. In this graph, the data points are plotted and they are not linear, so the reaction is not zero order. Natural log concentration of HCl versus time plot is not linear. Reaction is not first order. In this graph, the data points are plotted and they are not linear, so the reaction is not first order. 1 over concentration of HCl versus time plot is linear. Reaction is second order. In this graph, the data points are plotted and they are linear, so the reaction is second order. Analysis. Since the plot of 1 over concentration of HCl versus time produces a straight line, the reaction is second order with respect to HCl, with the rate equaling constant K times the concentration of HCl raised to the power of 2. Constant K is equal to 0.01064. For a reaction of 2.5 molar HCl with 3 grams of calcium carbonate, the rate is shown below, as well as the integrated rate law. This investigation is related to the deterioration of outdoor marble statue of calcium carbonate by acid rain.